Hello, everyone. This is Physical Science. We're working on Module 12. Today, we're going to be working on page 3 and 4 of the class notes. Now, we're starting with the rock cycle. The rock cycle is a series of processes that cause rocks to change from one type to the other. Now, it's called a cycle because you can pick it up any time in this particular process and get to another place. For example, you can start with metamorphic rocks. Metamorphic rocks can be worn down and become sediment over here. Sediment can be pressed together, become sedimentary rock, and then heat and pressure can again come to make it a different kind of metamorphic rock. Anywhere in this, you can pick that up. Let's start at magma and start with the process that gets us from magma to igneous rock. That any kind of rock can be melted and cooled. Could be sedimentary rock, could be metamorphic rock, whatever. It's melted and cooled. And this makes igneous rock. Now, at this point, whether it's igneous or metamorphic rock, it can be broken down by various processes. So rocks are broken into pieces. And then they get cemented together. You remember what kind of rock that makes? It makes sedimentary. Then remember the third process, which is going to bring us to the metamorphic rock, is heat and rocks. Well, we'll do it a different way. Rocks are changed by temperature or heat and pressure. So rocks are changed by temperature and pressure. And of course, that becomes metamorphic rocks. Just remember, wherever you start in the cycle, you can get someplace else by following the arrows. See, there's lots of different arrows. Igneous can become sedimentary. Igneous can become metamorphic. Sedimentary can get rocked or melted and become igneous. Sedimentary can get changed and become metamorphic. Metamorphic can get broken down and become sedimentary, and metamorphic can also be melted again and become igneous. It's a cycle. It can go around and around. Now let's talk about the Earth's water. Earth's water covers about 71% of the planet. That is a lot of the planet, and it's called the hydrosphere. Now, the hydrosphere is the sum of all a planet's water. And it can be any phase. Remember, the hydrosphere includes the solid, the liquid, and the gas. Now, on the Earth, salt water makes up about 97% of our water. A little bit more, so the fresh water only makes up about 2.75% of all the water on the planet. Now, out of that 2.75, most of it, 2.1%, is frozen in the icebergs and glaciers. Of whatever's left, we have about 0.7% that is groundwater, and groundwater simply means that it's underground. And then after that comes all the lakes and ponds, rivers, and streams that we can see, which is only 0.009% of all the water on the earth. Remember, it doesn't include the oceans. It's just the fresh water that we see. Now in the soil, there's another 0.005%. And in the air is water vapor, you have 0.001%. Now, 3 key facts about the Earth's water that we can take out of these statistics we've just listed out. Most of the Earth's water is in the oceans, and it's salt water. Now, most of the Earth's fresh water is stored in icebergs and in glaciers. The largest source of liquid fresh water is underground. It's groundwater. You know that a lot of us use wells as our water source in our houses, in our barns and farms. And those wells are tapping into the groundwater. Now, the hydrological cycle is also known as the water cycle. Most of us have learned the water cycle at one point or another in our schooling. The definition is it's the processes by which water is continuously exchanged between water sources. Now let's look at this a little bit. Here's a picture of the hydrological cycle. We're going to start up right here with some dark clouds. This is where I am. And out of the clouds are falling either rain or snow, and that's precipitation. Okay, precipitation is water that falls from the sky. And that's like liquid rain or snow, lots of different types of things that fall from the sky. Sleet, hail, anything like that. Now you've got a couple different things that the water does once it falls to earth as precipitation. One, it soaks into the earth, and that's called groundwater. The other thing is, and you can see it's actually pointing at the water that's flowing off in a stream, is called surface runoff. Okay, what is surface runoff? It's just that liquid water that runs along the top of the land, and it usually ends up in streams. Now, groundwater again, it's the water that's seeped into the ground and collected underground. Okay, so the next thing that happens is the water flows into streams, and it'll flow into bigger ones and bigger ones, and then into rivers, and eventually into oceans. But all the way along the line, depending on what the temperature is in the season, you've got evaporation happening. So that'll be our next one, evaporation. And just to explain that, water flows from small streams. I'll put from up here. From small streams into rivers, larger streams and larger streams, and then rivers, and eventually gets to the ocean. Now you have evaporation out of all these water bodies. Remember, evaporation leads to water vapor in the air that doesn't have any salt in it. It doesn't have any of the chemicals that is in the groundwater. Evaporation means liquid has become gas. And the key player in this is heat. Now, heat makes the particles move faster and faster, and then the faster particles break away. And once they've broken away from the water, they become gas. And the key player in the heat is the sun. Now, another source of water in the air is also called transpiration. Transpiration is where plants take in water in their roots, and it goes through the plant, up through the stem and out the leaves, and then it comes out. Some of it comes out as gas, and that's called transpiration. So it's very important to how water moves inside a plant. So it's the evaporation of water from the leaves of plants. And then condensation goes up into the sky, up into the sky. And now eventually, up in the sky, some of that water starts to cool off. And when it cools off, it condenses into teeny tiny little water droplets. It's not big enough to fall yet, but it's still bigger than water vapor. So it's in teeny tiny water droplets, sometimes around a piece of dust floating around or whatever. And once that happens, it becomes a cloud. Clouds we see are actually condensed water vapor. So what's going on is condensation. Now, condensation is where water vapor becomes water drops. Even if those little drops are too tiny to come together, they're still drops of water. And this has to do with cooling. So once they become condensed, then they can start gathering together, and they'll gather together more and more and more and more and more. And eventually, when they're heavy enough, they fall as precipitation. And then your water cycle starts again. So some of the benefits of the water cycle is that water vapor in the air moves around a lot. Like clouds moving on a day, that's water vapor moving one way or another. So if it's over the oceans, then the wind and the clouds can take that water vapor over the land. And then when it rains, it waters the land. Another benefit is that water that's in the salty oceans is not lost to us. It can come back to us in the hydrological cycle. Sort of peels off some of the not only the salt, but also the pollution in it as well. Now, some of the pollution is dissolved and can go up into the clouds, but a lot of it is left behind. The next thing that we're going to talk about is weathering and erosion. Now, weathering is simply the processes that break down rock and create sediment. Now we have both physical weathering and chemical weathering. Rocks can be broken down by chemicals and chemical reactions, or rocks can be just broken down through physical processes. Another name for physical weathering is mechanical weathering. And there's a bunch of different ways that this can happen. Now, this is the process of breaking rocks into smaller pieces with no change in the chemical structure. Now, if you're confused by this and you're trying to figure out, like on the homework, they give you two kinds of weathering processes, and you're supposed to label them physical or chemical. You need to think to yourself, was there a change in the chemical structure, or was there no change in chemical structure? And that will help you figure out whether it was physical or chemical. Now, one method of physical weathering is ice wedging or frost wedging. And what's happening here is that water gets into cracks in the rock. In the rock. And then what happens is that water freezes. Now, when water freezes, it expands. I'm going to make that an S. Freezes and expands. And then once it expands, it works, like pushes open that crack, and the crack gets bigger. The crack gets bigger, and eventually it'll break. Another process that breaks down rocks physically is abrasion. And this is where one rock is rubbing against another. Now, wind does this. It picks up the sand. Wind picks up sand and blows it against another rock, and that will wear it down. It's like sand blasting it. Another thing that causes abrasion, moves little pieces of rock around, is the ocean. The ocean moves the sand, and the sand rubs. And remember, sand is just tiny pieces of rock. An example of this is ocean glass. This is where it comes from. Third method of physical weathering is called biomechanical weathering. And this is done by both like plants and animals. So in plants, roots will grow into the cracks. Remember, roots are really small, and they're searching out any kind of water, any place that they can grow and attach themselves. So roots grow into the cracks in the rock. And once they've grown in there, the roots are going to get bigger. So the roots get bigger. And then it breaks the rock. Pushes that rock apart. Another way is by animals. Animals burrow into the ground and they rub up against the rock, and that rubbing and scraping pulls apart chunks of the rock, especially if it's already weakened by other things. So those are all physical processes that don't change the chemical structure. Now, chemical weathering is that the rocks are broken down by chemical changes. Now you can have, there's 3 different methods we'll talk about here. Hydrolysis reaction is a reaction with water. So the rocks can have a reaction with water. And other compounds, of course. And then once it has this reaction, some of the products are washed away. So you have a smaller rock. Now, you can have the same thing happen with carbon dioxide. Now, when carbon dioxide, which is CO2, mixes with rain, it leads to this stuff called carbonic acid. And this acid, when it gets on rocks, it will cause holes in rocks. It's eating away at the rocks. And again, whatever gets eaten away and changed gets washed away by the rain. The next one is oxidation. If you remember, oxidation is a reaction, just means reaction with oxygen. Okay, these reactions are very common because oxygen is very reactive and it's all around us. And often the products are very weak and don't stand up to rain and physical weathering. An example of this is rust. Now, iron is pretty strong and stands up to water, but once it turns into iron oxide, which is rust, then it can flake away with the rain, freezing temperatures, and eventually you're going to have a much smaller piece of iron than you started with. Now, caves are part of chemical weathering because water is running through the ground, picking up chemicals and reacting with the rocks and then washing away what is underground. It's washing away some of that rock and it leaves formations behind. And that we're going to talk about down here under groundwater erosion. Because erosion is the next thing we're going to talk about. Erosion is the processes that move sediment. So we have weathering that breaks the rock down into pieces, and then erosion takes this sediment and moves it away. And we're going to talk about wind, we're going to be talking about water, and we're going to be talking about glaciers. These are the 3 major ways that sediment has moved around on the planet. So if you're talking about land features that are caused by the wind, you have to remember the faster the wind, the more sediment is moved. And that what happens is when you move the sediment away, land features are left behind. So I'm going to put stuff moved away. Land features are left behind. Land features left. And of course, it happens in dry areas more than wet areas. Deserts are going to see this wind erosion way more than like we are. It happens here, but it's way more in deserts. So deflation are when these small particles are removed and a large rock structure is left. Now, if you look at the page of the picture at the top of the page, I'll come back here in a second, but I'm going to look at this. This is a picture of something that has appeared because erosion has taken particles away from it. You have this land feature left behind by deflation. Second thing is sand dunes. Sand dunes are hills made out of, small hills, but sand dunes are hills made out of sand. And the sand gets picked up and dropped into these hills. And you see them at the oceans, and you also see them in the deserts. They move. Dunes can move around because the sand on one side is again picked up and moved to the other, or to other sand dunes. Now, loess is a deposit of very, very small pieces of rock called silt or loam, and that's smaller than sand. Deposit of silt or loam. And this builds up over time. And they're very loosely connected. Oops. Certainly, if a flood comes along, a lot of this can get washed away pretty quickly. But in dry areas, it stays there because there's not an awful lot of water for it to get washed away. Or if you have just little bits of water come at a time, you'll have little formations left behind where the water ran off. Next, let's talk about land features left by water, both on top of the earth and under the earth in groundwater. So water runoff is just along the top of the surface, and this is what we see. So flowing water carries away sediment. Now, examples of this are when you see a V-shaped valley. Oftentimes, this has been created by water running through for a long time. It's just worn itself down, so now it's a V-shaped valley. Another thing that you'll see is waterfalls or streams themselves. Stream beds are often worn down by running water. Now, groundwater erosion is you have acidic water wears away the softer rock. So then the rock is dissolved in the water, and you can have various formations that happen because this water is creeping slower or faster, okay? Examples of this are caves and sinkholes. But you can also get these beautiful formations in the caves called stalactites and stalagmites. Now, stalactite and stalagmites are caused by dripping water. As the water drips very slowly, some of the deposits come out of solution because it's just going so slowly that they stick to the rest of the rock. And over hundreds of years, this will build up into something that looks like an icicle, or sometimes they join together and become columns. So a stalactite is an icicle-like stone formation. Now remember, a stalactite comes from the top and goes down. Stalactite has to hold tight. That's how you remember stalactite. Stalagmite is the same thing. It's icicle-like stone, but it grows up from the ground. And stalagmite looks like this. Now, deposition is simply the process that when water slows down, the sediment can no longer be carried along. It gets dropped. So when water slows down, sediment gets dropped. Okay, examples of this are meanders. So as a meander is a river that started out, following land features like this. And then these places where the water would slow around the outside and around these different areas get built up. So eventually you have this, where it becomes a much more pronounced curve where the water slowed down and dropped its sediment. Okay, those are called meanders. Oxbow lakes is when the meanders got so filled up that perhaps they left some of it behind. Okay, or maybe they changed directions, and they've left. Now perhaps they started going like this, and this is an oxbow lake. It's parts that have been left behind by a meander. Another one is a delta or an alluvial fan. Now a delta tends to be really big, coming out of a river. An alluvial fan tends to be a little smaller. So when you've got this a river coming out of a land and coming to the ocean, so here you have the ocean. As it gets closer and closer to the ocean, the land gets flatter and it tends to start spreading out. Now it follows the form of the land, so it spreads out, starts getting slower and slower and dropping its deposit. So eventually you're going to have a fan, and that's a delta. Now let's talk about land features by glacier. What is a glacier? Well, it's a mass of ice and snow that doesn't melt. And remember that it builds up and it builds up and it builds up year after year, and it doesn't melt, so it becomes much denser under the pressure of all that water and ice. So when it becomes denser, it becomes even harder for it to melt. So there's different things that go on around a glacier that don't happen normally in land, and one is abrasion. And what's happening is the bottom of the glacier and everything that's stuck to it breaks up the rocks that it runs over. And pretty much everything else it goes over. And then you have plucking happened where those broken pieces of stuff, we'll say broken rocks, because that's kind of what we're talking about. Those broken up rocks are picked up and carried away. Now, a glacier may only move maybe a foot or two during the year, but say it's around for 100 years. That means it's moved 200 feet and it's picked up this the sediment, this till, and carried it at least a couple hundred feet. Now, they have vast glaciers that carried stuff away, because they can tell because the different rocks are made up of, they're not like local to that area. They're local to a much farther away area. Now, till is simply that those rocks that get dropped. It was the stuck rocks that got dropped. A glacier erratic is simply a really big rock that got left behind. Now, if you look up glacier erratic on Google, you'll see pictures of stuff like this. Huge rocks, bigger than a person, left like that. Really, really amazing. Another formation left behind by glaciers is called a cirque. This is when you have U-shaped valleys. Remember, the V-shaped valley shows up more like up here with water erosion, but the U-shaped valley shows up with glacier erosions. Now, a glacial or a kettle lake shows up when a gouge fills in with water. Becomes a lake. The last two things we're going to talk about are an arête and a horn. An arête is a ridge that's formed when two glaciers come together. They meet. And then they stop. And they each pulled away some rock from that area, and a ridge is left behind. And then you also have horns. A horn is when three glaciers meet. And what's left is a point. The Matterhorn is a one of these horns. Remember, they scrape away all sorts of debris and till and stuff, and what's left behind is a horn. Okay, that finishes up our class notes for today. Thank you for listening, and if you have any questions, let me know.